Everybody say, everything okay? No. Everybody say tangents.
Tangents.
And you might say tangent, right? I guess I'm using plural right off the bat, but we're going to start with one tangent, okay? Do you remember using tangent in geometry before? You do? Okay, I saw some yeses. Do you remember what topic that was where we used tangent?
Trigonometry. No.
Yeah, I think you said it. Did you say trigonometry?
Yeah.
Trigonometry, right? Remember? Sine, cosine, tangent. So this is different. It's a different usage of the word, so you kind of have to forget that for a minute and then go on to this one. This is a different definition, different usage. They are sort of based on the same idea, but it's a different usage here. Okay, so what is a tangent? Here's a circle. To the best of my ability. Here's the center. A tangent is a line that touches the circle but doesn't cross it. What does that look like? If I can draw it right, it goes like this. And see how I crossed over? I didn't want to. I wanted to go straight right on that circle. Are you with me? That's a tangent. Okay, how do I know? See how the tangent's perched on the circle there, and you can think of it sort of angling, and as it does, the different part touches the circle at different places. What's the relationship between this angle of the tangent and the circle? It is exactly 90 degrees to the radius, or perpendicular to the radius. And so if you have more tangents, right? Here's another one, if I can draw it correctly. It's going to come, here's the radius, and here's the 90 if I drew it right. Sorry, can you see from there, Tiffany? I feel like I'm blocking them. And anywhere you draw another tangent, if I'm drawing it here and it's touching correctly, you can draw the radius and it'll be at a 90 degree right there. That's a tangent. Good? Okay. So what do we like to do with tangents? Well, if we take a circle like this and we draw a tangent here and a tangent here and have them connect into an angle right there, this creates some fun relationships for us. First of all, what do you call this piece of the circle here generically?
The arc.
Right? Any piece of a circle you can call an arc. Fair enough? And when I say piece of a circle, remember the definition of the circle is the set of points that are an equal distance from the center. Fair enough? So the circle is here. This is the circle. This is not the circle. Back in elementary school, it was the circle because they'd say, here's a shape, a circle. Now we're into what is the technical definition of the circle in high school, and so it's this line here that is now curved. It's not a line. It is this set of points that makes up this circle now. Fair enough? Okay. So what happens? There's an arc here, and then what is this piece here called, generically? It's also an arc, and there's an angle created right there. So two arcs and an angle. And if you think about it, me drawing this, if I have drawn this tangent correctly here to where it actually is at a 90 degrees to the radius, and this one is too at a 90 degrees to the radius, the way these touch right here means that they're touching at a point here, and the arc goes all the way from this side around to that point, and this arc goes from that point all the way around to this point. So the two arcs together equal how many degrees of rotation?
360?
They equal a total of 360 degrees. And so that's just the nature of the way the tangent comes in and touches at such a point here. And remember, the mass of a point is infinitely thin or small, non-existent. So when I draw a point there, it looks like it's got some size to it, but a real point doesn't. So this arc goes all the way up to wherever this one ends, and this one goes all the way up to where this one ends. They butt up against each other right there. So there's no loss of degrees in there. It's a full 360, the two of these arcs together. Okay. This arc on the outside is larger. So guess what it's called?
Major arc?
The major arc. Thank you. Thank you, thank you. And hence, what's the smaller arc called? Minor arc. Major and minor. Okay? Major arc, minor arc. If this arc out here is called C, and it equals 300 degrees, what degree of measurement is the minor arc?
60.
I'm going to call B, and it's 60 degrees. The question becomes now, what's the measurement of this angle in here? And if you can imagine these tangents being shorter, like as this would come more to a point, and it kind of looks like a cornucopia in my mind right now, okay? As these become shorter, minor arc could shrink as the length of these tangents where they intersect was decreased, right? So this one we're doing 360. What is the measurement here? This A, we're going to call this now A over here. A is related by a relationship of C minus B divided by 2. And I don't know if you remember, but that was the same relationship that was formed for the arcs that were being divided up by the chords that we dealt with, actually secants that we dealt with 2 days ago, or whenever that was we dealt with that, last week maybe. So if this one's 300, then the measure of A is simply 300 minus the 60, which is here, that's B. 300 minus 60 is 240. So 240 divided by 2, and A equals 120 degrees. So this measurement in here of this angle will be 120 degrees. Major arc, minor arc, tangent, intersection, I didn't cover that. But just think of this point here where the tangent is coming in contact with the circle. We call that an intersection. And then the Schoology will just practice you on different ways of going about this and plugging it in. It's kind of a fun relationship, but it's not too complicated. I think I'm done.